Welcome back. This is Intro to Physical Anthropology. I'm your instructor, David Leitner, and today we're going to talk about Homo erectus slash ergaster. Which you call it, it depends on whether you're a lumper or a splitter. We'll talk a little bit about that, but also get to know this hominin pretty well, because this is the hominin that really sets the stage for the next stage of evolution, of human evolution. So, let's get started. First thing to know about Homo erectus, it is the first hominin to leave Africa. That it is the first time we see hominins that are no longer just restricted to the African continent, which also means they are going out and adapting to vastly different environments all the time. Now, you remember a little bit earlier, we talked about how the environment is constantly changing back and forth between these periods of glaciation and these interglacial periods. So ice age, not an ice age, not an ice age, which includes pretty severe drops or rises in temperature over relatively short periods of time. Well, this hominin is flourishing in this environment. Flourishing so much that they are spreading out everywhere. This is a map of about 1.7 million years ago. First time we see Homo erectus is about 1.8 to 1.9 million years ago, and then within 100,000 years or so, we see them in the Republic of Georgia at a site called Dmanisi, which you can see at the top there. They are some of the oldest. Well, they are the oldest Homo erectus remains outside of Africa. And what it shows us is that this was a different kind of hominin from the very beginning. Their home ranges must have been considerably larger, and they clearly expanded and were willing to expand out much more readily than others were. Perhaps they were following different kinds of animals that they depended on. Perhaps it was simply just curiosity. We don't know for sure, but it is clear it was a powerful thing, because then within another 300,000 years, we see them in Southeast Asia, Malaysia. By 800,000 years ago, they are well into Europe, North Africa, and Asia as well. So they have very, very successfully colonized most of the world at this point. Maybe colonize isn't the right word, because there were no other hominins there to take the place of. So really, they are settlers. They sort of came in and settled in these landscapes. As they stay in those landscapes, though, some regional variations begin to develop. And over time, as we'll see next week, we get these regional variations that begin to produce new species of hominin, with the Neanderthals in Europe, the Denisovans in Asia, and Homo sapiens in Africa. Homo erectus anatomy. Homo erectus is the first of our species that really starts looking a lot like us. There's a pretty safe bet that this may be the species that first started losing body hair, that they were using fire, that they were making complex tools and sharing information back and forth. Possible the roots of the ability to use language are in this species as well. So it's a pretty fascinating sort of species to look at. Okay, how do you know one when you see one? Well, compared to modern humans, the Homo erectus skull has a much more angular vault that you can see. So whereas ours is more rounded towards the back here, there's this sort of slope and a much flatter sort of area on the top of the skull here. Although their faces are much less prognathic than Australopiths, they are still more prognathic than ours. So, and this is something I'm going to give you a little cheat here. One of the few anatomical traits absolutely unique to Homo sapiens is the fact that we have chins. It's a little bit of bone that juts out instead of just sloping back the way this does. So they don't have chins. Homo erectus does not have chins. The vault itself, the cranial vault, is much lower than it is in Homo sapiens. They maintain a relatively massive brow ridge, whereas we have greatly reduced, or oftentimes completely no brow ridge whatsoever. They possess a bit of bone on the back here called the occipital torus. You can see it's sort of a flattened donut shape on the rear view here. And if you look from behind, the shape of the skull is, whereas ours is very round, theirs looks almost pentagonal here. 1, 2, 3, 4, 5, 6, 7, yeah. Or septagonal, I should say. Septagonal. They have this thickening of bone, which isn't quite a sagittal crest, but it is a sagittal keel, indicating that along with these large zygomatic arches here, or cheekbones, that they were still emphasizing chewing, just not nearly as much as Australopiths did. So that's sort of the grand tour of the cranium. The next thing we need to point out are what are the changes cranial capacity, and not just in terms of gross capacity, but where is this growth happening? The cranial capacities for Homo erectus are from 700 to 1200 cc's, with an average of about 900 cc's. We definitely see an increase over time in cranial capacities for Homo erectus. They are around for quite a long time, at least 1 million years, perhaps 1.5 million or more. And the early increases in cranial capacity seem to coincide with increases in overall body size, because that is certainly happening. The body size of early Homo is smaller than later. Early erectus is smaller than later erectus. But by the end, we start seeing not just an increase in overall brain size, but an increase in brain to body ratios. That is, an increase in encephalization. That means their brains are bigger than you would expect them to be for their body size. So, although perhaps intelligence itself is not, if we use brain capacity, cranial capacity as a proxy for intelligence, which can be problematic. We need to be careful about doing that. But certainly, at some point, oh, there's an earthquake going on. And it's still going on. Not a big one, but I'm here in the valley. That means it must have been a big one somewhere. I'm going to hit pause. So the interesting thing about the increase in cranial capacities in Homo erectus is that it's not just the whole brain that's getting bigger. There are some parts that are getting bigger faster than others. And specifically, as you can see here, in the top picture on the right, you have an Australopithecine skull. On the left, you have Homo erectus. Now, if you look just behind the eye bones, the orbits of the eyes there, you'll notice there's this restriction, this pinching behind the eyes in the Australopith, and much less so in the Homo erectus. That is one of the main areas where we see the growth of the cranial capacities there, because this region, the frontal lobe of the brain, is what's increasing faster than other parts of the brain. Why is that important? The frontal lobe is where most of our executive functioning occurs. It's where social intelligence occurs, planning, executing those plans, making decisions about what other people are thinking, that sort of thing. All of that occurs up here. So although these are all to limited degrees capacities of other primates as well, they're getting fine-tuned in this period, or turbo boosted, or I don't know, however you want to put it, but they are improving. That seems to be a conclusion we can draw from that. So the brain size increase isn't just willy-nilly. It's not just in one place. There are particular regions that are that appear to be getting selected for. So whatever is attached to those regions may be something that's getting selected for as well. Now, there is regional variation and variation over time in this brain size and shape. It makes determining exact causes very difficult, but nonetheless, if we sort of move on here to see a plot of the cranial capacities of various fossils of this isn't just Homo erectus, but many of them are. This is just Homo erectus. I don't remember my own slides. It's okay. So, as you can see, it looks a little bit random, but there is a definite trend here over time that there is a general increase in size. So, although the spread is quite wide, there is a very definite direction that brain size is headed in. Now, from the splitter perspective, we don't just have erectus. We have erectus and we have ergaster. Ergaster is reserved for less robust specimens, so they have thinner cranial bones and less pronounced brow ridges, that sort of thing, and tend to be in East Africa and, very importantly, Republic of Georgia. Why Republic of Georgia? Well, that indicates that if most of our early African specimens fall under ergaster, it makes sense that the one in Georgia falls under that as well. It helps confirm that that was an early migration. Homo erectus proper is then reserved for mostly the Asian specimens that have been discovered, which tend to have thicker cranial bones and more pronounced brow ridges. Now, it's important that we don't assume that just because ergaster was ergaster in the beginning in Africa that they never changed. In fact, actually, it's important to remember that once Homo erectus spreads out, although they're not completely cut off from one another, there's quite a bit of gene flow that can occur. Still, at the extent of the ranges and on these different continents, there is regional variation occurring. There are different selective forces at work, and in addition, they are far enough away that certain mutations may get concentrated in certain parts of the overall range and not in others. So what happens after Homo erectus leaves is going to be as important as the fact that they left in the first place, and we'll see that in the next chapter. With that said, we'll move on next time to see a little bit more about this pattern of world travel and why it's significant. And thank you again for joining me, and I will see you again soon. Take care.